Hello, my name is Walter Ellsworth, and welcome to my presentation of Lab 1 Physics 2212 Charge Tapes. The entire purpose of this lab was to use everyday household tape and observe the transfer of electrons and then calculate and estimate the amount of electrons transferred based on the recorded observations between the two tapes. As shown in Figure 4, the two tapes, one eventually floated above the other because of uh, like forces or like charges repelling. Uh, the models in this lab were that each strip of charge tape was used to represent a point particle, is seen over here to the right. Object B is tape B. Object A is tape A. The principles of this lab were that the dimensions of an atom were used along with the known charge of an electron, and that was used to calculate the number of atoms and electrons lost and gained in between the interaction and when they were charged. And then Newton's second law, force equals mass times acceleration, was used to calculate the force of gravity, which was then equated to the force of repulsion. And Coulomb's law was used force equals the constant times to first charge times the second charge over the distance squared. The results of this lab were that when the two tapes were placed near each other, the charge tapes repelled each other noticeably, and the repulsion was strong enough that the tape that was suspended loosely between the two books floated slightly, and the charge on the tape was found to be around 7 nanocoulombs, and it was deficient around 4.38 times 10 to the 10 electrons. The assumptions in this lab were that the tapes acted as point charges, the concentration of the charge at the center, and the assumption was that the air resistance was completely negligible, and that the force of gravity was equal to the repulsion force. In order to create a floating effect, it would have to counteract the forces of gravity, and the assumption was that the surface of the tape was evenly charged instead of pockets of high charge and low charge spread across the tape surface. We assumed an even charge and a single point charge. Uh, the system and the surroundings. The system were the two pieces of tape, and then the surroundings were the rest of the environment in the lab. The initial conditions were that the two pieces of neutral tape with handles were hanging freely, and then one other piece of neutral tape that was smooth onto the desk. And then you see here to the right, the tapes were created by pulling them off the base tape and then tested with hand and then a pen. A charge pen, sorry. And then a piece of tape was stuck in. This is the summary of the process. A piece of tape was stuck and smoothed down to the desk. Then tape A was laid on top of this piece and quickly pulled away. And then the piece of tape was hoped to be charged, and then was hung freely. And then various objects, hand, a pen, and then notice that the tape was attracted to negatively charged objects that indicated a positive charge. And then when the process was repeated with tape B, they repelled, indicating that they were of the same charge, both positive, and the distance was measurable. The recorded distance, it was used with a ruler, so I rounded 0.15 meters or 0.015 meters or 1.5 centimeters. And then the force of gravity calculated was 1.96 times 10 to the negative 3 newtons. That was used the mass of the tape. And then the gravity constant. There was no acceleration in the tape, so using the following formula, I was able to calculate the electrical force, and because the tape wasn't, it was a constant, so there was no acceleration. And then setting the force equal to the force of gravity and solving for Q, I found that the charge was about 7 nanocoulombs on one piece of tape. And then this is the coding for the model of the two tapes. This shows the opposing forces, and this is all the coding. Possible errors in this lab were that the model and real life experiment both show what occurs when two like particles enact a repelling force on one another, and then the model is a vast oversimplification of this. There could be an uneven distribution of charge along the tape surface. The charge could be lost through the whole process too. It's not a completely accurate model. And then what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charge objects? They'd be about the same. Like charges repel, so if they flop, it's the same, or they flip. What does it mean? Is it important to handle the charge shapes as little as possible? What happens when the charge shapes come into contact with their hands or other objects? They lose their charge. They get electrons because they're positively charged, and they become neutral. Thank you.